Hello and welcome to our technical webinar today. Today I would like to talk about KNX RF. I would like to give you some hints, some ideas what you should be aware of and also things what you should typically avoid. Yeah, let's start. So what is the general technique behind KNX RF? So we are using here a radio frequency of 868 megahertz. Unfortunately, this frequency is not just reserved for a KNX communication. Also, this this frequency is also used for many other systems, purposes, and so on. So we are really sharing that frequency, and also the other systems might have impact also to the quality of the transmission of the data. But anyhow, yeah, we are talking about a range in an open field, so that means outdoor with about 100 meter. But that's not typical. So normally these devices are installed in a building, and here we are talking of a transmission rate, a range of about, yes, maximum 30 meter. If you might have more, but yeah, calculate with these 30 meters as maximum. And also it really depends on many other yes, situations and so on. I will come to that later on. A bit more about the topology. So for example, here on the left side, you do have here some RF components, switching, dimming, blind actuators, and so on. All are RF based, so they do not have any TP connections. You would like to also to set up and also to control it from a TP line, so you need also that green cable. And additionally, really to convert the telegrams from the green cable from KNX TP to RF, you need the media coupler. That's our blue device here. And all of these devices are assigned to that media coupler, and they are communicating via RF in both directions. So these devices are assigned to the media coupler, and very important, these group of devices, or all the devices which are assigned to that media coupler, belongs to one specific unique RF domain. So this domain has its own name, and only devices which are really in that domain can talk to that media coupler. The media coupler itself has also a physical address, and as you can see, it has a 0 in the end, so it's acting as a normal line coupler. And the RF line has also its own line ID. If we have a second group of devices, as you can see here on the other side, which also are RF domain, which also belongs together, also communicating with their own media coupler. And as you can see, this group of devices have their own domain. So the domains are completely different. And also it has its own line number. Also the media coupler for that green domain, I will say, has its own physical address. And if one device from this side would like to talk to the devices on the other side, they cannot talk directly via RF. They always have to go through the media coupler over the green line to the other media coupler and then talk to the other devices. Just that you are aware of how these things work together. So what is the difference between twisted pair, TP, and RF? Okay, twisted pair, it's definitely based on the green cable, and I just would like to give you a short example to better understand what is the impact or what is the advantage of that green cable, of the wired-based communication. So for example, you have here a group of people like a group of devices all connected to one TP segment or to one TP line. They have a very clear number of people which are connected to that line, and also they can see each other and they know who is connected to that line. And for example, if the blind actuator, that one person here, would like to talk to another one, to the switching actuator sending a telegram, then he will wait until all the people in the room are quiet. Then he will send the telegram from the blind actuator to the switching actuator. The switching actuator will confirm the telegram, and done. We have here a very solid, very robust communication. All the others in that room, they are quiet, they are listening, but they do not disturb that communication. And so very robust and very reliable communication. So that's what we have typically on the green cable. What happens if we have a situation with the radio communication, with RF communication? And that looks pretty different. As you can see here, if we have here two people who would like to talk to each other, they cannot wait until it's completely quiet. They even do not know how many people are around them. And the other people will never ever wait till they have done their communication. And that's really the challenge of the RF communication. So here we have much more factors which have a negative impact on the quality, but also on the range, but also on collisions and so on based on that communication. So that's really the problem what we have here on the RF communication. So what does that mean in general? So if you wait on the RF signal on the RF band until it's silent, until you can definitely send with a good quality, you might have to wait a pretty long time, and that's not really a reliable connection. So the idea behind the communication on KNX RF is that before a device would like to send a telegram, he will listen, is the channel empty? If so, is there silence? If there is no silence, then he will wait a short time, and after that time he will immediately send his telegram. Anyhow, it could be that even then the channel is still blocked, or there are other available, but he cannot wait forever. So that's what happens. If you are just talking too much, if you have many devices on the bus, on the RF side, which are always talking or talking too often, the risk is just very high that you have more collisions. So what does that mean for our configuration? Very important, just send telegrams which are really necessary, which are needed. Don't waste, don't block, don't overload the RF band with telegrams which are not used. So you do not have to send, for example, the temperature every 10 seconds. Otherwise, if you do that with many different devices, you can just block your own RF channel with some communications. Yeah, and also the other side is really just configure or just use RF devices where they are really necessary. Ensure that they are in a good range to the media coupler, and ensure that they cannot disturb themselves. So the other side is really sometimes you really have a media coupler, which is, for example, here, and the blue dots here on that slide are our RF devices, switching, dimming, actuators, and so on. The media coupler, he has a specific range where he can send and where also its telegram will get received by the devices. But unfortunately also we have few of the devices, of the blue dots, which are just outside of that range. That means that they will not be able to communicate with the media coupler. They will not receive telegrams, they cannot send telegrams back to the media coupler. It will not work. So we have to find a way how we can extend that range. And therefore we have a function implemented which is a repeating function. So where one device also can act as a repeater and then extend the distance between the media coupler and the devices. So for example, if we have then a second device like this one as a repeater, then the media coupler will send the telegram to the repeater. The repeater will just, yes, resend all the telegrams from himself, and so he has its own detection range, and now it's possible that this device will also get the telegrams from the media coupler. That's the idea. Repeating just means that what the repeater hears on one side, he will send out, and vice versa. So nothing else, all the telegrams which belongs to that domain. That's what the repeater will do. So on the other side, very often you do not need know exactly what is the range of the devices, which devices are really getting a good signal, which devices are getting a bad or non-signal. So which devices makes really sense to act as a repeater? But first let me show you where you can set the repeating function. So in Luxor Living we have here in the middle, in the device list, here a box where you can mark which RF devices should act as a repeater. On the KNX side, you can have it under the properties of a device, and also here set retransmitter to yes, and then it works. And now, for example, you do not know which devices should act as a repeater. So you decide, okay, I have again here the media coupler, then this is a repeater, and then probably, yes, also this one I will configure as a repeater, and also the one at the top is a repeater, one, and so on. So I have set now several devices to a repeater, and we have now the same game. So the media coupler will send out a telegram to that range, and now these three media couplers, these three repeaters will also receive the telegram and will resend the telegram. And now you can see we have a pretty high overlap of the telegrams. And now also these two repeaters will will receive their telegram, and now we have suddenly a huge chaos and a huge mess of telegrams and of data on the communication side. So now we have a good signal definitely here on that, but the signal is always aborted or with collisions and so on. So it's never ever a reliable communication. So that's the reason why it isn't a good idea to set many devices as a repeater. Just set one device which is really on a very good position and use it as a repeater. So never ever set too many devices, enable the repeating function. Yeah. So you never know what will happen if you have so many repeaters. No good idea. Then we have other factors which have an impact to the quality of the signal. So we have damping. What does damping mean? So typically the media coupler or the RF devices are somewhere installed in a wall, in a flash mounted box. And also this wall here behind has an impact to the RF signal. But also the quality of that wall. So for example, if you have stone, if you have wood, or if you have concrete or whatever, it has different impacts. And that's what I would like to show you on the next slide. So for example, if you have a concrete wall with a flash-mounted RF device, then you have here, yes, that range where you have a pretty good signal. Like if you have a lamp, yes, it can directly send out, and all the devices which are here in that green area will definitely get a pretty good signal. But also, it's not just that area. Also in other areas around, we still have a signal. It's not that good. It does not have that high quality, but you still might be able to communicate with devices. So if you have a wooden wall, then very similar with the devices in front of it, but wood does have a less damping factor. So it will be able or possible to send the signal in a better way through the wall. So here we have much better conditions for RF communication. Or if you have really, sorry, the other one was stone. Now we have concrete, and concrete is, yes, very, very bad. So here you have almost no signal around it, or very low signal. You have to really configure any repeater or so in the next door or in the next room next to it. So that really has an impact to it. So that's just something what you should be aware of. Ask what kind of material has been used for the building, for the walls, that you have a better idea what will work and where it might be difficult to use RF communication. So, but you just have to be creative and have good ideas. Where can I, for example, also hide any RF devices, like for example here in that plastic box above that lamp. There we have 230 voltage. You can switch with that switching or dim with that dimming actuator the lamp itself. But also you can configure then the device which is really installed in that plastic box here as a repeater. And now you have a pretty good repeating position which can send telegrams to all of the devices which are in that room or in rooms next to it. So just think about it where it's necessary, where you can have those kind of devices. You just need 230 volt. Yeah, and then also, yes, configure this device as a repeater, and you have a good solution for that situation. So yeah, what kind of summary I have in general? Yes, again, we have not a RF frequency which is just blocked for KNX. It's also shared with Zigbee, with baby phones, or within oceans, or many other devices. So we have not an impact. So what's really going on? So that you should just be aware. Try to configure the devices in that way that you send as less telegrams as possible, just the really needed telegrams. Yeah, repeating, yeah, less is more. Really think about where is repeating necessary, where you can put the repeater in the in a device or so, that he really can send out its telegrams very good. Start with one repeater, then verify if it has been improved or not. If not, then use another device, configure it as a repeater. If it is working, fine. But please do one repeater after each other, not all of them in parallel. That wouldn't help, as I have explained already. Okay, and installation, you should really think about it, where you install your media coupler, your RF devices and so on, that they also are installed in positions where the damping is not that high. Okay, so we have additional documentation, handbooks and so on about the RF situation. That's our RF system handbook. You can also download it from our webpage. And there you find few more hints exactly also where this is described in detail. Yeah, few more information about the configuration of our RF actuators in general. So we have really a wide assortment of devices, and all of these devices are really communicating KNX data secure. What does it mean? The telegrams are encrypted, they cannot be hacked, they cannot be manipulated. Only certified telegrams will be received and will be executed. That's very important. Also, what we have done in the last half year or year, we also have increased the operating distance range due to the fact that we have increased the transmitting but also the receiving properties of the devices itself. So we can really say now also the operating distance has been significantly increased. Various applications, as you will see later on. Frequency 868 megahertz, as I have mentioned, and the transmission rate on the frequency is about 16 kilobit per second. Yeah, distance. So also very important. It's really implemented on the standard on the KNX S mode and based on the KNX RF 1R standard. So we are really implementing using the full KNX standard, and so we are fully compatible here. What kind of devices we have right now for KNX RF? We have here on the very left side the switching actuator, which has really which is designed also to handle a high LED load. We have a dimming actuator, which you can see over there. Also ideal for dimming of LEDs up to 250 watt LEDs. Then we have a blind actuator, a heating actuator for classic heatings, and very new also now we have a heating actuator for e-heating, especially when you have additional e-heatings in the bathroom or on the floor, which can act then independent of the classic heatings. And we have here the TU4, which is a 4-way binary input. And for sure the media coupler, as I have explained, which is necessary really to communicate between the TP line and the RF devices. And as I have mentioned, all of the devices are really KNX secure. So each devices, they have some inputs. They have 2 binary inputs except of the TU4. This device has 4 inputs. And these devices can be used for various purposes. Either you can just connect a normal push button to it, independent which vendor you prefer. But also you can add additionally that temperature sensor to channel 2. So each device can then also act as a classic temperature sensor and send the temperature of a room to the bus, which then can also be used for heating regulation. Yeah, very important. Both channels are really potential free, so please do not set any potential to these inputs. And also, if you are just using the devices at the beginning in an unprogrammed way, then the channels are configured in that way that they control standard functions of the device. So for example, if you're using on a switching channel, channel 1 on off, then also the output channel will switch. Independent, or even if the device is in a factory setting mode and it's not configured yet. So that's also possible for dimming, for blinds, and so on. And very important, the binary input has the same functions as the applications of our standard push button interface, the TA2468S, and so on, except of the fact that they cannot be an output or driver output LED. Okay, each device has its own secure card, as you can see in here, with a sticker on it, with the QR code, but also with the text of that code of the FD-SDK. This code is definitely needed to add the device to the ETS, and please ensure that this card and also this sticker will find its way into the project documentation. The other thing is also when you set secure or when you add secure devices to your project, you have to set a password for your ETS password per project file. Very important, and also you should not lose that password. Otherwise, you cannot open again the project file. Yeah, if you want to have secure communication, then also you need to make your project file secure as well. Very important. And by the way, also the sticker, which you can find on the secure card, you can also find on each device. Okay, and again, yes, I think that's a very nice sentence. Yeah, building, even if it's new, without smart building technology, it's an old building. So always think about how you can really put smart building, our technology into, or KNX or Luxor Living into the building, and really, yes, configure the building as a modern building. Okay, now I'm at the end of my session. Thanks for joining the session. Thanks for listening. Thanks for your time. If you have further questions, just get back to us. And yeah, thanks and have a nice day. Bye.